Hello, so we're going to talk about using equations to solve word problems. And I just want to point out I'm not saying real world problems because I realize that the word problems I've selected, there's like really no chance you're ever going to do this in the real world. But I will provide a short discussion on some applications and some things that you guys can do to apply your knowledge of equations. So here's an example, and it reads, on a 520-mile trip, Theo and Cleo shared the driving. Cleo drove 80 miles more than Theo drove. How far did each person drive? And this is an example of what I mean. Like this scenario, you're probably never going to run into this scenario. But the practice of using equations to model a word problem and solve a word problem is very valuable. And this example kind of gets us started. So if one way we could do I guess approach this as a strategy is to come up with an expression for how far Theo drove, and that's why we've divvied it up this way: how far Theo drove, how far Cleo drove, and then together they drove, and then what would that equation be? So we can kind of split it up with different equations, or rather different expressions, and then use them to form a final equation. So I'm going to write below this so I have a little bit more room. So how far did Theo drive? So Theo and Cleo shared the driving. Cleo drove 80 more miles than Theo. I don't know how far Theo drove, but I'm going to use an X to represent the amount of distance, the amount of miles that Theo drove. How far did Cleo drive then? Well, he said it was, the problem said 80 miles more than Theo. So I'm going to say that's X plus 80. So I've just expressed relative to each other Theo's and Cleo's driving. And together they drove a total of 520 miles. So then what would our equation be? Well, our equation would be the amount of miles that Theo drove, or X, plus the amount of miles that Cleo drove, which would be X plus 80. And those two together, Theo and Cleo, add up to 520. So now I've got this equation, and I used an expression to model Theo's distance and an expression to model Cleo's distance. I used a variable for the first thing that I didn't know. And if I had used a variable for Cleo's, then I would just have had to, like if I said that Cleo was X, then Theo just would have been X minus 80. And those would have been equivalent ideas, because Theo would have driven 80 miles less than, or rather, Theo drove 80 miles less than Cleo. So there's lots of ways to go about this. This is not the only way. But now that I've got this equation, I can go ahead and simplify and solve. So when I subtract 80 from both sides, I get 2x is equal to, what would that be, 440? Mine's not working that great. So x would be equal to 220. Now we want to remember what we said. We said that Theo was represented by x. So that would mean, in this particular example, that if I did this right, that he drove 220 miles. But we have to remember that it said Cleo drove 80 more miles than Theo did. So that would mean that Cleo drove 220 plus 80 miles. And I just want to check my work. So 220 plus 80 is 300. And 300 plus 220 does indeed equal that total of 520. So that makes a lot of sense then, and I know my answer is right because Theo drove 80 miles less than Cleo, and they both add up to 520. Now let's do a little bit of a harder one. And I might as well insert my talk about why we care about being able to model the world with equations, and it's because there's so many things equations can do for us. Algorithms that are processes or step-by-step processes when we're telling machines to do something, or just a process for getting something done. We can program computers and all sorts of different things to do those algorithms for us, and an equation is one form of an algorithm. So our stoplights are run by algorithms. Really everything in the world is run by a process that's really programmable now in this day and age. So the ability to express things that you read and situations that are in your mind in terms of an equation is a valuable skill. So something that I think might be more applicable is, could you program an Excel spreadsheet perhaps to calculate your net pay given a specific tax rate, a specific 401k percentage contribution and insurance premium? Could you program an Excel spreadsheet to calculate something of interest to you? And there's so many great tutorials online on how to work with Excel or with other programming tools. So I would say don't let this define how you're using equations. In class with my students, we're going to broaden our perspective, and I would encourage you to do that as well. Okay, before I go over this problem, I want to ask you guys to take a shot at this. Try to break up each part, each person's age into an expression, and then write an equation that relates them all together, and see if you can solve this by yourself before looking at my work. Okay, so this problem says Chris is 3 years older than David. David is twice as old as Rick, and the sum of Rick's age and David's age is 81. How old is Rick? So this is an interesting puzzle. Of course, it's never going to happen to us in real life, but it's an interesting puzzle. So let's put Chris here. Let's make David here. Let's put Rick here, and I'll go ahead and stop there. Let's come up with an expression for these three guys' ages. So Chris is 3 years older than David, and David is twice as old as Rick. So I'm going to go ahead and start with a variable at Rick. So I'm going to make Rick X. And the reason I'm doing that is because from reading the problem from my experience, I think it's going to be easiest to start with Rick as my variable. But it wouldn't really matter where you started. You could tweak it to make it work. So X is going to express Rick's age. But I can't use a y or another variable for David or Chris, because then I'll have one equation with two variables, and that's not going to work. So David is twice as old as Rick, though. So that just means that David needs to be expressed as 2x. But it says that Chris is 3 years older than David. So I know what David is, because he's twice that of Rick. So 3 years older, so he's going to be 2x plus 3. And then it says the sum of Rick's age and David's age, so Rick plus David, is 81. How old is Rick? So it looks like Chris was actually kind of just extra information. We didn't really need that to answer the question. So it says the sum of David and Rick's age is 81. So one equation we could write using these expressions could be 2x plus x is equal to 81. And that's going to give us the value of x. And once we know the value of x, we're going to be able to plug it in for each of these people, person's ages, the expressions, and calculate their age. So 2x plus x equals 81 is the same thing as 3x equals 81. And when I divide 81 by 3, I think I get 27. So that means x must be equal to 27. So it's the question itself asked, how old is Rick? So I'm saying that Rick is 27 years old, because Rick was expressed as x. So I'm going to say Rick is 27. But that would mean that David is twice the age of Rick, so it's going to have to be 54, right? Let me double check. Is the sum of 27 and 54 81 like the problem said it should be? And it looks like it is, so that's great. And just because I can, I'm going to go ahead and find Chris's age. So Chris, therefore, must be 54 plus 3, or 57 years old. So again, I'm using expressions to model each component of the problem, and then I'm putting those components or those expressions together to form an equation and then solve for the missing variable that I've used. All right, thanks.